Hey everybody, this is the Trig tutorial video for the warm-up that you just completed. If there's any problems that you missed, I'm going to break this video up into little chunks so that if you don't need to watch all of them, you don't have to, but look at the ones that you missed. First one, find the area of a regular nonagon with an apothem of 6 kilometers. We're going to round to the nearest tenths place. So they're letting us use decimals, which means that's a big clue that SOHCAHTOA might be coming. First thing, we got to know what shape we're dealing with. Regular means equilateral and equiangular. Nonagon means 9 sides. So I'm just going to put n equals 9. You do not need to draw the entire nonagon. We've seen this trick before. Just draw part of it, because really you're going to be analyzing one of the triangles to get what you need. So I'm going to start by drawing the center of my polygon. The apothem, remember, is a perpendicular segment that goes from the center. You drop it straight down at a right angle until it hits the side of the shape, and it splits it in half. Okay. I'm also going to sketch in my 2 radii so that I can see the triangles that are made. So let me do a little bit of labeling. This is a radius, because it goes to the vertices, and the apothem goes straight down the middle. So we'll call that A. We need to know how much this central angle is between the green radii. Remember, if I was to sketch in all of the triangles inside of that nonagon, there would be 9 of them, because it has 9 sides. So I would take 360 degrees in the middle, and I would split it into 9 equal pieces. So if I do that, oh, there we go. 360 divided by 9 gives me 40 degrees. So that angle between the green radii is 40. But remember, the apothem is going to bisect that angle at the top as well. So it's going to split it into 20 and 20. Not only does it bisect the bottom, the segment, it also bisects the angle at the top. All right, so now what am I going to do? Before I get the area, I need to know what the apothem is and what the perimeter is. Well, check to the apothem. They already told me that's 6 kilometers. Before I can get the perimeter, though, I'm going to have to figure out what this side length is and then multiply it by 9. And before I do that, I'm going to have to figure out what half that side length is. So I'm going to start by just focusing on one of these little triangles inside. So we'll call this step 1. There's half my triangle. There's 20 degrees at the top. The vertical piece, the height of that triangle, is my apothem. And I'm going to call x half the side length. So that entire side length is 2x. Look at your reference angle. You have the side across, the opposite, and you have the side that shares that reference angle and the right angle. So you have the adjacent. I'm going to write a fun phrase that we're used to at the top, SOHCAHTOA. Which one uses O and A? Before I say it, pause me. Think to yourself, how would you set up this trig ratio? Okay, so you should get tangent, opposite over adjacent. Tangent of 20 degrees, opposite x, adjacent. Oh, wait, what do we know? Oh, yeah, the adjacent. We already know that. That is 6. I'm going to label it. This is 6. They told us that. So x over 6. I'm going to multiply both sides by 6. That'll make the 6 disappear on the right-hand side. So half that side length of the nonagon is equal to 6 times the tangent of 20. We talked about this in class the other day. You can get a decimal for that, but I would hold off until the end of the problem. Keep everything in terms of tangent right now. Just leave it as 6 tan 20. So this piece right here is 6 tan 20. So call this step 2. That means the side length is double that. Well, if I take 2 times 6 tan 20, that's 12 tan 20. I just double the number in front. You don't touch the tangent part. Okay, so this is 12 tan 20. But wait, there's more. You got to get the perimeter. Look back at the formula at the top. 1/2 apothem times perimeter. There's 9 sides to this nonagon. So I'm going to take that side length and I'm going to multiply it by 9 to get the perimeter. 9 times 12 tan 20 would be 108 times the tangent of 20. So there's my perimeter. Now, last step, we crank out the area. The apothem we already had. They gave it to us and the problem was 6. Let's double check that. Yeah. Apothem was 6. So I'm going to write down my givens. 6 kilometers. My perimeter is 108. times the tangent of 20 degrees. If you want to put kilometers now, you can. You don't have to. So I'm just going to use my area formula now. 1/2 the apothem times the perimeter. Apothem is 6. Perimeter is 108 tan 20. And now, since this is my last step, I can type all this into one line on my calculator. I'm going to use 0.5 for this 1/2, just so I don't have to deal with the parentheses. But everything else is going to pretty much get typed in as is. And let's see what this comes out to. So 0.5 times 6 times 108 times, hit the tangent button, and then put 20 degrees in, close the parenthesis. You should get 117.9. Okay, it's going to stay a 9 because if you look to the right, there's a 2. If it's 5 or higher, we would round it up to 118, but if it's less than 5, we're going to keep it as a 0.9. And our units would be kilometers squared since we're dealing with an area. Okay, so that covers the first problem. Okay. If you need to keep going, if there were other ones you missed, keep watching. If that was the only one you missed, you can stop watching the video. Number 2, this one's a little bit shorter. Find the area of the triangle below, round to the nearest tenths place. At this point in the chapter, we've seen 2 formulas for the area of a triangle. One case is when you have the base and the height. So if you actually have a right angle drawn in and you have a base, I would just use 1/2 base times height. In the notes from 10.5, though, we saw there's a special case whenever you have 2 sides given, call it A and B. Actually, I think in the notes we called it B and C. The letter choice doesn't really matter. What really matters is that you're looking at side angle side. Let's say this is B, let's say this is C, and let's say that the included angle between them is angle A. Instead of dropping the height and going through all of the work, we saw that this just turns into area is 1/2 the product of the 2 side lengths, B and C, times the sine of the angle squeezed between them, sine of A. Side times the angle that's sandwiched between. Side, angle, side. So you can only use this with SAS. So if you look at the picture I gave you, you have 2 sides, 112 and 100, and you have an angle squeezed between them, 26. Side, angle, side. So we can use the formula. It's 1/2 the product of those sides, 112 times 100, times the sine of the angle squeezed between them. Sandwiched between those 2 sides is a 26-degree angle. And like I did in the last problem, I'm going to use 0.5 instead of typing in 1/2. It's just easier to type on the calculator. 0.5 times 112 times 100 times the sine of 26. Okay, 2454.9. It's going to round up because if you look at the 8, it's followed by a 7. 5 or higher would round up. 2454.9. And did we have units? Let's see, centimeters. So this would be centimeters squared since it's an area. It's 2-dimensional. Okay. If you didn't get this, there's a good chance your calculator might be in radians. So just remember, you can always go and switch the mode by hitting the mode button, go down to the 4th row and make sure degree is highlighted, and that should fix the issue. Okay. All right, so that covers problem 2. If you got problem 3 correct, no need to watch. If you missed problem 3, take a look. Find the area of a regular pentagon. I'm going to make a comment. That means 5 sides. A radius of 12. Okay. So this is where the vocab comes into play. Radius, remember, goes from the center to a vertex of the pentagon. It's not the apothem. So if I draw the pentagon, and since there's not that many sides to it, I am going to draw the whole thing this time. You don't have to if you don't want to. There's my 5 corners, my 5 vertices. The center to the vertex is a radius, and strategically, as usual, I'm going to draw 2 of them. This is a radius, that's 12. This is a radius, that's 12. This was the problem at the end of the notes the other day that we said if you use SOHCAHTOA, it's going to take a long time because you're going to have to use SOHCAHTOA once to get the apothem, but then you're also going to have to use SOHCAHTOA again to get the side length. And then you're going to still have to get the perimeter. It just takes too long. So my recommendation would be think about, well, this pentagon is made up of 5 triangles and they're all congruent. So they all have the same area. If you can find the area of one triangle, you can just multiply it by 5 and then you're done. That'll take up the entire pentagon. In order to do that, I would find this central angle at the top between those blue radii, because then you're going to have side angle side. These are your two sides that are including that angle, the 12s. The angle, the central angle, we've done this trick before. It's 360 divided by the number of sides or the number of triangles you can fit inside of the shape. So in this case, that's 5. 360 divided by 5 would be 72. And I'm not going to split it in half this time because I'm not dropping an apothem. I'm just looking at this triangle. I'm going to zoom in. You can see you've got side angle side. There's a side, there's a squeezed angle, there's a side. So the area of just this one triangle, I'm going to use my formula we did from the last problem. 1/2 the product of the sides, 12 and 12, times the sine of the angle in between is 72 degrees. I'm going to type 0.5 times 12 times 12 times the sine of 72. This is just one triangle. That's 68.476, whole bunch of stuff. You can keep that long decimal on your screen. I'll round it on paper, but you want to keep it on your calculator. 68.476, I'll write it as. That's one of these. Now you got to keep in mind though, there's 5 triangles inside of this pentagon. So my last step that I'm going to do is I'm going to take that and I'm going to multiply it by 5, since there's 5 triangles inside the pentagon. Okay. Don't round the shortcut or the short answer. You want to round the long one. So on your screen, you should already have the 68 point whatever. Just hit times 5. And there's your full area. 342.4. And did we have units? Let's see. Centimeters squared for this one. Okay, just a lot shorter than having to use SOHCAHTOA, find the apothem, find the side length. That 1/2 BC sine A comes in really handy whenever you have side angle side. So that will conclude this video. Let me know if you have other questions. I'm happy to help.